Hello, I am Lysander De Sutter, Senior Researcher at the Battery Innovation Center of the MOBI Research Group. It is my pleasure to introduce you to the topic of smart sensing and self-healing for the batteries of the future. What these future batteries exactly will look like in terms of chemical composition is still being investigated by researchers around the world. However, they all aspire to develop and enable a technology that shares the four following qualities: high energy density, long lifetime, high power, and low cost. However, additional challenges complicate the development and integration of novel battery technologies, primarily that battery performance varies greatly over time. This can be attributed to a number of unwanted side reactions that occur at the material level, which ultimately induce capacity fade and impedance growth, which in turn can lead to potential safety hazards in the form of dendrite short circuits, for example. As such, it is extremely important to monitor and control batteries accurately during their operation over their entire lifetime. This is conventionally achieved by implementing a battery management system, or a BMS. The BMS ensures that the voltage, current, and temperature of each individual cell stays within its optimal safety boundaries. Additionally, the BMS uses the measurements on these parameters, the voltage, current, and temperature, to determine the battery states, such as the state of charge, which shows how much energy is left in the battery, and the state of health, which shows how much energy the battery can still hold compared to when it was new. These important battery states, however, cannot be measured directly and have to be estimated using complex algorithms and battery models. Most of these activities rely on the use of sensors outside rather than inside the battery cells at the moment, limiting the knowledge to macroscopic properties but overlooking internal chemical and physical parameters of prime importance for monitoring battery lifetime. This, implantable sensors, which are integrated within the battery cell, are increasingly attracting interest. This will allow us to measure unexplored quantities, gain deeper knowledge of the physical parameters, and gain a deeper understanding of the parasitic chemical processes within the cells. This will drastically enhance battery reliability and safety. Parameters such as temperature, pressure, strain, expansion, and electrolyte composition are among the valuable options. Besides offering fundamental insights to battery operation, smart sensors would also allow to develop a next generation of state estimator and battery management systems. As previously shown, battery degradation is the result of unwanted chemical changes within the cell. The concept in batteries is to reverse these changes to restore the battery to its original configuration and full functionality. Specifically, self-healing functionalities in batteries will target the auto repair of damaged electrodes to restore their conductivity, regulation of ion transport within the cell, and minimizing the effect of parasitic side reactions. The introduction of self-healing mechanisms to the field of battery technology has been rather slow, due to the challenging chemical environment they have to operate in. But the topic is now rapidly gaining momentum. Recently, several self-healing concepts for batteries have been discussed in literature, such as the self-healing polymer substrates, which allow to repair damaged electrodes and restore their conductivity, self-healing polymer binders, which prevent the loss of electrical contact between cracked active material particles, for example in silicon anodes. Another promising concept are functionalized membranes, which can trap unwanted molecules and prevent them to react with other materials inside the cell. Self-healing electrolytes, on the other hand, contain healing agents that are capable of dissolving unwanted depositions inside the cell. And then finally, a promising future concept are encapsulated self-healing molecules. These consist of healing agents contained in microcapsules. When needed, the healing agents can be released by providing the right stimulus. It should be noted that sensing and self-healing functionalities are intimately linked. Our ultimate vision of smart batteries integrates both these functions at the same time. So this means that signals from the integrated sensors within the battery will be sent to the future battery management system and analyzed. If problems are detected, the battery management system will send a signal to the actuator, triggering the stimulus of the appropriate self-healing process. This game-changing approach will maximize reliability, lifetime, user confidence, and safety of the batteries of the future. To accomplish this vision, MOBI was recently granted 2 Horizon 2020 research projects funded by the European Commission. On one hand, we have the Bat Forever project, where we will develop autonomous polymer-based self-healing components. And on the other hand, we have the Spartacus project, where we will develop integrated smart sensors and state estimation techniques. Being part of both projects ensures that our research group is on the forefront of these innovative research fields and prepares us for the future to link them together.